All right, here's the Chapter 4 practice test. The first thing we're going to do is we're going to graph this parabola in standard form. A is 1. There's nothing in front there, so that means A is 1, B is -8, and C is 6. We will use C later on in the chapter, and it's also the y-intercept. Alright, so the first thing we do is we calculate what h is, the x-coordinate of the vertex. So since b is negative, we have a double negative here, so it's -8 over 2 times a, which is 1. So that would be 8 over 2 times 1 is 2, so h is equal to 4. So we make our table of values, x and y, and I put 4 in the center, and then I pick a point on each side. 0, I always like to use 0 when I can. That's 4 steps below the vertex, and then I'm going to go 4 steps above to keep the symmetry going here of the parabola. When you put 0 in, that's easy because 0 squared and then 8 times 0, all that disappears and you're left with 6, which is why that 6 is important in standard form, because that is the y-intercept. If this is 6, this is also 6. So really the only number you need to calculate is this one here, because these two answers are always going to be the same, and if you use 0, the calculation is easy. So I'm going to do something squared minus 8 times something plus 6. That's what y is equal to. And again, you could put 0, squared. You could put 0 in here, and you could put 4 in here, you could put 8 in there and figure out the answers. So now I'm going to put 4 in for x, because I need to know what that is. Okay, the calculator would work here, or you can just figure out the answer. If you use the calculator and you use negatives, you want to make sure that you have parentheses around here. So 4 squared is 16 minus, that's would be 32, and then plus 6. This and this would be -16 plus 6 would be -10. So the answer is -10. So you graph the 3 points, make the parabola. There's the 6 here, the 1, 2, 3, -10, and the 6, 8. Oops. 8, 6, and then 4, -10. So that point is not there. I was thinking of a different problem. There we go. So it's 4, -10. There's the points. All right, point 1, point 2, point 3, miscounted. Okay, now we're going to do the h and the k down here. So I don't have to figure out any formula for h and k because this is in the vertex form. The only thing I have to do is I have to understand that there's a minus -3 here because it's minus h and it's plus there. So what we're not seeing is it's really x minus a -3 quantity squared minus 6. So there's a double negative we're not seeing. So it really does go 3 spaces to the left. So it's -3, and then k is -6. And then I picked 0 and then 3 spaces on the other side. That's what I was doing. I was thinking about the next problem because it's 4 and I was thinking 3 for some reason, getting ahead of myself. So 3 spaces here, 3 more spaces would be -6. So that way I have the equal spacing on each side of the vertex. And then 0 goes in. So we just put 0 in for x. So that would be, I'll move over here where I have space. So it'd be something plus 3 squared minus 6. That's what is equal to y. So I put 0 in here. Now I have to calculate it because it's not in standard form. When you put 0 here, those two disappear, and then the answer is just 6. But down here, if you put 0 in, you have to actually do the calculation. So that'd be 3 squared is 9. So it'd be 9 minus 6, which is equal to 3. So that's the y value associated with 0. So this is a 3, and then this is also a 3. So 0, 3 is right there. -6 is right here. 1, 2, 3 right there. And then 3 right there. Okay? So -6, 3, 0, 3. Yep. And there's our points. So this point goes to here, this point is right there, that point is right there. Perfect, there's my two parabolas. Okay, so the next page is all factoring stuff. And when I made this out, question number 5 really needs to be -4. So I'm going to change this to a -4 because it makes the problem actually work. So I'm going to white it out, and instead of just writing over the top of it. Okay, it's after school. I just did my first yawn during this video. I'm boring myself. Haha. Okay, so 2 sets of parentheses, put an X in each. So I'm going to make your 2 sets of parentheses, X and X. Now you have to think about ways to make 60, and there's lots of ways to make 60, but the one that comes to mind to make the 7 would be if they differ by 7. So 12 and 5 make 60, 5 times 12. And then this needs to be positive, and this needs to be negative, because 12 minus 5 makes the 7 in the middle. The next one is all positives, so it's all positives, easy, cheesy. And this times this makes that, and then if we add the 6x and the 8x together, we get the 14x in the middle, so that one works pretty well. All right. 2x and x, and it's the only way to split this up because 2 is a prime number. So then we need a 4, so we can do 2 and 2 or 4 and 1, and it turns out it has to be 4 and 1 because the 2 needs to match up with the 4. So the order matters on this one because there's 2 in the front. So this times this is -8, or 8, which needs to be negative, so it's -8, and then +1. So that's how that one factors. 3 is a prime number, so there's only one way to split this up, is to 3x and x. And then 11, there's only one way to split that up, 11 and 1. Now if you put 11 here, it's only going to match up with the x. It won't make anywhere close to 34. So we need a bit +11 and then +1. So this times this makes that. So then we've done this checking thing where I call it the half donut trick. So this and this makes 1x, and this makes 11x. And if you add 33x, my bad, 33x. So if you add 1x and 33x, that makes the 34x. I forgot there wasn't a 1 there. So 3 times 11 makes 33. So it's 33 and 1 make the 34. So that's how we check to make sure. And it looks kind of like half of a donut, so that's why we do that way. Okay, the next one, the difference of 2 perfect squares is just 5x plus 7 and 5x minus 7, because these are both perfect squares. So 5 times 5, 7 times 7, x times x. One's plus, one's minus. And the reason why that is because the middle terms go away. So I'll half donut this one to show it to you. So this times this makes 35x, and this times this is negative 35x. And notice that cancels out, and there's no x's in the middle. So the 5x and 5x make the 25x squared, and the 7 and the 7 make 49, and then it's minus, right? But the middle part, and do you see the donut, right? It looks like a donut, half of a donut. See, there's half the donut there. Okay, so the blue is the answer. So the orange is just me, checking my work, and then there's the answer. This is also a perfect square trinomial. 9 is the first, well, I guess we could do that with the other one. But so it's not 9x and 1x, it's 3 and 3, because these are perfect squares. So I'm going to factor it into the same thing times the same thing. So it's 3x and 3x and plus 5 and plus 5. And then since it's a perfect square, you could write it 3x plus 5 quantity squared like that. So these ones here, we're factoring out the common factor first and factoring a second time if possible. So 6x, and we get x plus 3. So this times this makes this times this makes that. So 6 is a common factor, and x is. Over here, 5 is the common factor. So we get x squared minus 25. And then that's the difference of 2 perfect squares. So we factor that into x plus 5 and x minus 5. So that's the answer on that one. You could try and factor this one like this one up here, but that's the harder way to do it. There's no common factor of 3 in these, so I just had to factor it like this. Where down here, the common factor is 3. And so I can take that out by factoring it to the front. So this times this is this, this times this is this, this times this is that. So then we bring it down again, and it factors a second time. Minus 2 minus 4. So that's the final answer, because that times that makes that. We've got negative 2, negative 4 makes negative 6 in the middle. Here, there's an invisible negative 1 there, so I'm going to bring it out to the front by factoring it out, dividing it out. I'm left with x squared minus 8x minus 9. And then x and x minus 9 plus 1. So we have negative 9x, and then plus 1x makes the negative 8 in the middle. All right. Next page. Taking out the greatest common factor and then solving. So now we're going into the solving phase. So we're going to take out x, and we're left with x plus 8. So then we do the t, set each factor equal to 0, 0 product proper t. So if this first factor is 0, the whole thing is 0. If the second factor is 0, the whole thing is 0. So I set each factor equal to 0. I don't have to solve that. Subtract 8 over, and I get x equals negative 8. So there's my two answers, the two places where the parabola crosses the x-axis. So that's what I'm looking for in these problems. I want to know, where does the parabola cross the x-axis? So if I do this, it crosses at 0 and it crosses at negative 8. So the parabola looks something like this if I was to graph it. This one here, 5 and x is the common factor, so x minus 3 would be left. So this times this makes this times this makes that. And then we got 5x equals 0, x minus 3 is equal to 0. Divide by 5, and you get x is equal to 0. Add 3, you get x is equal to 3. All right, so there's the two answers there. Solve by factoring. Boom, 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 boom. This is the more traditional factoring, where here you're just taking out one factor, a monomial. So it's a monomial times a binomial. Here it's two binomials times each other, so that there's two terms. This one here I made super easy, so you can just concentrate on the solving part. So it's x plus 1 is equal to 0, x plus 2 is equal to 0. You set each factor equal to 0. This times this is that. 1x and 2x makes 3x in the middle. Subtract 1, x is negative 1. Subtract 2, x is negative 2. Solve by factoring. So the only thing different here is this one has a little bit more difficult factoring. And pause. All right, and I'm back. So what I'm going to do here is split this up into two parts. We're going to do negative 7 here and positive 4 over here equals 0. So that makes the negative 28. This makes negative 7, positive 4 makes negative 3 in the middle. So set each factor equal to 0. And we get add the 7 over, so x equals 7. Subtract the 4 over, x equals negative 4. So that's how we handle that situation. The factoring on these two is just a little bit more challenging. This was probably the most challenging one for factoring in all the factoring, because there's just more choices. 2x and x, this one isn't too bad because 2 is a prime number. And then you could do 2 and 2, but actually it's 4 and 1. So put 4 over here, 1 here. That makes the 8, and then the 1 makes the 9 in the middle if these two are positive. So proper t, make a t, and then x plus 4 equals 0. Subtract the 1 over, 2x is equal to negative 1. Divide by 2, x is equal to negative 1/2. Subtract the 4 over, x is negative 4. Then here there's just more choices. Is it 6 and 1, 3 and 2? Is this going to be 2 and 2 or 4 and 1? And it turns out that 3x and 2x is the way that this factors. And then the 4 needs to match up with, so it's going to be 4 and 1. The 4 needs to match up with the 2 to make 8. And then the negative 3, right, so this is positive 8, negative 3 matches up to make the positive 5 in the middle. So proper t, make the t, and we get 2x minus 1 is equal to 0. Subtract 4 over, 3x is equal to negative 4. Divide, x is equal to negative 4/3. Just leave the fraction. Add the 1 over, 2x is equal to 1, divide by 2, x is equal to 1/2. All right. 18, 19. Now we're solving by the square root method, 2 of these. So we're going to subtract over the 2, so just do regular algebra, and then take the square root. 16. Square root each side, x is equal to plus or minus 4. Basic algebra on these ones here again, so add 7 to each side. 2x squared is equal to 72, divide by 2, x squared is equal to 36. Take the square root of each side, x is equal to plus or minus 6. And these two answers make this true, so I can do 6 squared or negative 6 squared times 2 minus 7 is 65. Completing the square on these two here, prepare by adding the 6 over. So we get x squared. Uh-oh, am I running out of ink? Nope, I should be good with ink. I had to check my ink reservoir. X squared plus 4x, add the 6 over. Leave a blank space. Now I'm going to fill that blank space. So half the middle term is 2, squared is 4. So we add 4 to each side. So I'm filling those two spots with the same number, because if you add to 1, you got to add to the other side. Factor x plus 2 times x plus 2. That's the whole point, is we created something here that factors is equal to 10. Rewrite it. X plus 2 quantity squared is equal to 10. Now I do the opposite of squaring, which is to take the square root of each side of the equation, and I get x plus 2 is equal to plus or minus 10. Subtract the 2 plus or minus the square root of 10. Subtract the 2 over, x is equal to negative 2 plus or minus the square root of 10. Same procedure over here, except for there's a negative there, so the factoring is going to be negative negative instead of positive positive. So we're going to subtract the 10 over, x squared minus 8x equals negative 10. So I have to create this blank space here. What do I fill it with? Half the middle term squared would be plus 16, so I add 16 to each side. So I'm filling those two spots with the same number, because if you add to one side, you got to add to the other side of the equation. Okay, factor it. Now, the factoring has to always be correct. It's positive, positive, so it's 2 positive. Minus positive would be negative and negative, and then 6. Rewrite it. X minus 4 quantity squared is equal to 6. The opposite of squaring is to take the square root. So I'm left with x minus 4 is equal to plus or minus the square root of 6. Then I add the 4 over, x is equal to 4 plus or minus the square root of 6. Now there's two answers here. We're looking for two answers, like plus or minus 6 are nice answers, nice integer answers. But what does this mean right here? It means that this parabola crosses at 4 plus the square root of 6, and then you could come up with a decimal approximation for that by typing it into the calculator, or 4 minus the square root of 6, and then that would be another decimal approximation. So these are the two answers exactly, and then decimal approximations would come out of those by typing them into the calculator. The last one here, I'm asking you to solve it with the calculator in the left-right guess business. So I go to y equals, and I type it into the calculator. So y equals, and that's another parabola I had in there. So we get 3x squared minus 12x, and then plus 6. Now we go to graph. So I hit the graph button. I'm going to do zoom standard just to make sure. Zoom, and then number 6, which is zoom standard. Make sure I have the scale right. And that's 10 spaces in each direction. That's what zoom standard does. So there's my parabola. I'm going to make just a basic sketch of it right here. So here's the basic parabola. So it comes down and then goes back up again. And what I'm looking for is I'm looking for where it crosses right here and right there. What are those places where it crosses? So I mark the left side, I mark the right side, and then I do my guess. So left, right, guess. And then when I repeat the process over here, I do the same thing. Left, right, and guess. I know it seems weird. You're marking on the left side of it. And I did this for a student today. So if I was to turn this sideways, and that's the actual answer, see it, that's the left side and the right side of the guess. And if I take it and turn it sideways and look at it this way, that's the answer, and I'm marking on the left and the right side of it. There's the left and the right side. So that's why we do it that way, and it has to do with finding the zero. So we got negative or positive y values up here, negative y values down here, and I'm looking for 0 in the middle, and that's how I do it. Go ahead and let's go to, I have left, right, guess. So how do you get to that? You go second, calculate, 0 of the function, move, I'm already on the left side, so I hit enter, move to the right side. And I was helping a student today, and I said left, right, middle. So you're putting you're marking the middle of it where it crosses. So the answer is 0.59 if we round it 2 decimal places. So the answer here is 0.59. So that's where it crosses approximately. And then the other place where it crosses is over here. So I go second, calculate, 0, and then move myself here, mark it, move myself over here, mark it, go back, and enter. So 341. So it crosses here at 3.41. So those are the two approximate answers for x. So x is approximately equal to, and x is approximately equal to 3.41. All right, so there's the whole video of all 23 questions, and it took less than 23 minutes. So enjoy going through this. Or I hope you enjoyed going through this.